Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this lecture on time and work. So in this lecture, we are going to solve 25 practice questions on time and work. So let us start with the first question. P can do 2/5 of the work in 10 days and Q can do 4/5 of the work in 16 days. If both of them start working together, then what then the time in which the work can be done is. So let us have a look over the solution. So in this question, the following information is given to us. So P can do 2/5 of the work in 10 days. That means if P have to complete the work, then it will require 25 days. Okay. And Q can do 4/5 of the work in 16 days. That means if Q have to complete the work, then he will require 20 days. So I can write P equal to 25 and Q equal to 20. So take the LCM of both of them as we have studied in the theory class, and one day work, the efficiency will be given by 100 upon 25, that is 4, and 100 upon 20, that is 5. Okay. So the total work that A and B can do together is in a day is 9. That means A plus B is equal to 100 upon 9. So the correct option here is option B. Question number 2. Nakul and Ram are working on a production company. Nakul takes 6 hours to make 32 products, while Ram takes 5 hours to make 40 products. How much time will they take working together to make 110 products? So Nakul can make products in 1 hour. So it is given that Nakul can make 6, so 32 products in 6 hours. That means product made by him in 1 hour will be 32 upon 6. So similarly, Ram makes 40 products in 5 hours. Then the product made by him in 1 hour will be 40 upon 5. So in 1 hour, the total product that can be made is 32 upon 6 plus 40 upon 5. That is equal to 40 upon 3. Therefore, working together, 40 upon 3 products can be made in 1 hour. Therefore, 110 product can be made in 1 upon 40 upon 3 into 110 hours. That is equal to 8 hours 15 minutes. So the correct answer here will be option B. Question number 3. Neha takes 5 hours to type 40 pages, while Sunil takes 6 hours to type 60 pages. How much time will they take working together on different computer to type an assignment of 180 pages? So solution. So Neha can type 540 pages in 4 hours. So therefore 1 hour to type 8 pages. And similarly, Sunil can type 60 pages in 6 hours. That means he types 10 pages every hour. Therefore, 18 pages can be typed by Neha and Sunil in 1 hour. So this is the total number of pages that Neha and Sunil can together type in 1 hour. That is 18 pages. And in the question, it is asked that if they have to type an assignment of 180 pages, then how much time it will require. So 180 pages can be typed by Sunil and Neha in 10 hours. So the correct option here is option D. Question number 4. P and Q were assigned to do a work for an amount of 1200. P can P alone can do it in 15 days while Q can do it in 12 days. With the help of R, they finish the work in 6 days. Find the share of R. So here A is given to be 15, B is 12, and we have to see what time C takes. So the together time is given to be 6 days. So if you have to take the LCM, then you will get 60. And now 1 day work efficiency, if A, the work efficiency of A will be 60 upon 15, that is 4. And 1 day work efficiency of B will be 60 upon 12, that is 5. And the combined work efficiency will be 10. So the combined is 10, for A is 4 and for B is 5. Then 10 minus 4 plus 5 will give you the work efficiency of C, that is 1. So the amount is divided according to their ratio of 1 day work. Therefore, 1200 is divided among P, Q and R to the ratio of 4 is to 5 is to 1. The share of R is equal to 1 upon 10 into 1200, that is equal to 120. So the correct option here is option B. Question number 5. P can complete a work in 12 days working 8 hours a day. Q can complete the same work in 8 days working 10 hours a day. If both P and Q work together working 8 hours a day, how many days can they complete the work? So P can complete a work in 12 into 8, that is 96 hours, and Q can complete the same work in 8 into 10, that is 80 hours. So P is equal to 96, Q equal to 80. So the LCM of these two is going to be 480, and the 1 day work efficiency of P will be 480 upon P, that is 5, and Q is 480 upon 80, that is 6. So the combined work efficiency is going to be 11. So they both work together 8 hours each day. Therefore, 1 day work of P and Q will be 11 into 8. Hence, they can complete the work in 480 upon 8 times of 11, that is 60 upon 11. So the correct option here is option A. Question number 6. A can finish a piece of work in 24 days, B in 9 days, and C in 12 days. B and C start the work but are forced to leave after 3 days. In how many days the remaining work was done by A? So this is a very interesting question. This time there are 3 people, A, B, C. A finish a work in 24 days, B finishes it in 9 days, and C finishes in 12 days. And B and C start the work but are forced to leave after 3 days. Okay, so B and C. Now A is not in the picture yet. B and C are working together to complete that task, and they worked for 3 days and they were kicked out later on after 3 days, and A continued the work. So how many days A will take to complete the work? So let us see the solution. So first of all, it is given that A takes 24 days to complete the work, B takes 9 days, and C takes 12 days. So the combined LCM will be 72, and 1 day work efficiency of A is 3, 1 day work efficiency of B is 8, and 1 day work of C is 6. So if I have to see the combined of A, B, C, it will be 17, and 1 day work of B and C is 8 plus 6, that is 14. So now, since B and C were working together for the first 3 days, so work done by B and C is 42. Okay. So the remaining work will be total work, that is LCM, minus total work done in 3 days. So the total work was 72 and 42 is already done, 42 units. That means 30 units are remaining. So the number of days to complete the remaining work by A is 30 upon 3, that is 10 days. So the option correct here is option A. Question number 7. X and Y can do a piece of work in 20 days and 12 days respectively. X started the work alone and after 4 days, Y joined him till the completion of work. So how long did the work last? So in this question, X was doing alone for the first 4 days and Y joined him later. So let's see how much time the work will get completed. So here we have X and Y. X take 20 days and Y take 12 days. So the combined, it will be 60 units. And 1 day work is 60 upon 20, that is 3 units. And 1 day work by Y is 60 upon 12, that is 5. So the combined work done by X plus Y in a day will be 8. Okay. And 1 day work of X is 3, that is already computed by us. So in 1 day, X completes 4 units work. So in 4 days, how much work will be completed? 3 times 4, correct? So that is 12. So how much work is remaining? The total work was 60 and 12 is already done. That means 48 units are remaining. And now since the Y have also joined, then we have to see how long the work is going to last. So number of days to complete remaining work by X and Y will be 48, that is remaining work, and 3 plus 5, that is efficiency, is work done in each day by X and Y. So that is 6 days. The number of days to complete the whole work will be given by 4 days plus 6 days, because 4 days X did alone and later in 6 days X and Y did combined, that is 10 days. So the option B is correct here. Now, question number 8. X and Y can do a piece of work in 24 days and 32 days respectively. They start together, but 4 days before the completion of the work, X leaves off. Find the total number of days for the work to be completed. Now, in this question, something different is happening. So, we have two people, X and Y. They started to work together, but before 4 days before the completion of work, X left the job. And now Y have to complete the work by himself. So definitely it's going to take extra time. So how many days will be required when this happened? So first of all, let's do the stuff which we did in each and every question. So X takes 24 days and Y takes 32 days. So the LCM is 96. So the total work is 96, and 1 day work efficiency of X is 96 divided by 24, that is 4, and for Y is 96 divided by 32, that is 3. So X plus Y combined, if they work together, so in each day they can do 7 units of work. Okay, and last 4 days work of Y was 4 into 3, that is 12, and the remaining work is 96 minus 12, that is 84. So the remaining work was done by both X and Y, and the number of days taken by X and Y to complete the remaining work, 84 upon 3 plus 4, that is 12 days. The total number of days for the work to be completed is 4 plus 12, that is 16 days. So the option correct here is C. Now, question number 9. A can complete a certain work in 35 days and B can complete the same work in 15 days. So they worked together for 7 days, then B left the work. In how many days will A alone complete 60% of the remaining work? So, work A takes 35 days, B takes 15 days. So the LCM is 105. So the 1 day work done by A is 3, 1 day work done by B is 7. So combined, they are going to do 10 units of work each day. So work done by A and B for 7 days is 10 times 7, that is 70. Correct? So the remaining work is 105 minus 70, that is 35 units of work. And now we want to find how much time A alone takes to complete 60% of the remaining work. The remaining work is 35 units. So what is that 60% of 35 units? So that is 35 times of 0.6, that is 21. So the 60% of the remaining work was completed by A in 21 upon 3, that is 7 days. So the correct option here is option A. Question number 10. Amir and Akbar can finish a task in 30 days and 15 days respectively. Akbar worked on task for 8 days and left the job. In how many days can Amir alone finish the remaining work? So again, Amir equal to 30, Akbar equal to 15 days. So the LCM will be 30. So the 1 day work by Amir will be 1 and 1 day work done by Akbar is 2. So when they do it combined, it is 3. So the work done by Akbar in 8 days is equal to 8 times of 2, that is 16. So the remaining work is 30 minus 16, that is 14. So Amir will finish the remaining work in 14 upon 1, that is 14 days. Hence the option A is correct. A can do a piece of work in 20 days, B in 30 days. They worked together for 7 days and they both leave the work. Then C alone finishes the remaining work in 10 days. In how many days C take to complete the whole work? So again, A is equal to 20, B equal to 30. So the total work is 60. And 1 day work done by A is 3, 1 day work done by B is 2. So the total work that A and B can do together in a day is 5. So work done of A and B for 7 days is 5 times 7, that is 35 units. So the remaining work is 60 minus 35, that is 25. So the time taken by C to finish the remaining work will be 25 upon 1 day work, that is 10. Therefore, 1 day work of C is 5 upon 2, that is 2.5. So the time taken by C to complete the whole work is 24 days. So the option correct here is option C. Question number 12. A and B together can complete a work in 20 days. They started together, but after 4 days, A left the work, and the remaining work was completed by B alone in 24 more days. In how many days can A complete the entire work alone? So the fraction of work done by A and B in 4 days is given by 4 upon 20, that is 1 upon 5, and the remaining fraction of work is equal to 4 upon 5. So 4 upon 5 fraction of work was done by B in 24 days. Therefore, B can complete the whole work in 24 times of 5 upon 4, that is 30 days. Now, A, time taken by A is unknown. B takes 30 days. So the LCM and combined they take 20. So the LCM will be 60. And 1 day work efficiency of B is 2 and combined is 3. That means A alone did only 1 units of work each day. Hence the number of days taken by A to complete the entire work is 60 upon 1. That is 60 days. So the option correct here is option D. X can do a piece of work in 24 days. When he had worked for 4 days, Y joined him. If complete work was finished in 16 days, in how many days Y can alone finish the complete work? So the fraction of work done by X in 4 days is given by 4 upon 24, that is equal to 1 upon 6. The fraction of remaining work to be finished by both X and Y is 1 minus 1 upon 6, that is 5 upon 6. And they finish it in 16 minus 4, that is 12 days. Therefore, the 5 upon 6th part of the work is finished by X and Y in 12 days. Therefore, they can complete the whole work in 72 upon 5 days. That means X is equal to 24, Y is unknown, and combined is 72 upon 5. So the LCM is going to be 72. So the 1 day work of X is 3 and 1 day work of combined is 5 units. So the remaining will be, so the work done by Y will be 2 units. Therefore, Y alone finished the work, complete work in 72 upon 2 equal to 36 days. The option B is correct. A can complete a work in 25 days and B can complete the same work in 20 days. They started the work together, but B left after 4 days and A continued to work. In how many days will the entire work will be completed? So A takes 25 days, B takes 20 days, so the LCM is 100. So work done by A in 1 day is 4 units, work done by B is 5 units. So the combined they do it in single day is 9. So work done by A and B in 4 days will be 9 into 4, that is 36. So the remaining work is 64. So A finishes the work in 16 days and the total number of days for the work to be completed is 16 plus 4, that is 20 days. The option correct here is option B. A does 2/5 of the work in 9 days. B joined him and they together completed the remaining work in 6 days. In how many days B alone can finish the whole work? A completes 2/5 of the work in 9 days. Therefore, A complete the whole work in 45 upon 2 days. So the remaining fraction of work is equal to 1 minus 2 upon 5 because 2 upon 5 is already done by A. That is equal to 3/5 of the total work is completed by A and B in 6 days. Therefore, they can complete the whole work in 10 days. So A is equal to 45 upon 2 and A plus B combined is equal to 10. So the LCM is 90. 1 day work efficiency of A is 4 and B is 9. So for B, for combined is 9. So B will be 5. Therefore, the time taken by B to complete whole work is 90 upon 5. That is 18 days. So the option correct here is option D. So question number 17. A, B and C can do a work separately in 18, 36 and 54 days respectively. They started the work together, but B and C left 5 days and 10 days respectively before the completion of work. In how many days was work finished? So A takes 18 days, B takes 36 days, C takes 54. So the total work is 108. So the work done by A in 1 day is 6, B is 3, and C is 2 units. So combined work done by A, B, C in a single day is 11. Suppose B and C does not leave till work get completed. So the work done by B and C for 5 days and 10 days respectively will be 5 times 3 plus 10 times 2. That is 35 units. Now total work is 108 plus 35, that is 143. So the number of days to complete the whole work when they work together is 1 upon 43 upon 11, that is 13 days. So the option correct here is option B. A and B can do a job in 10 days and 5 days respectively. They worked together for 2 days, after which B was replaced by C and work was finished in next 3 days. How long will C alone take to finish 40% of the job? So A takes 10 days, B takes 5 days. So the total work is 10, and work done by A in a single day is 1, and work done by B in a single day is 2. So the combined A and B would do 3 units of work. So the work done of A and B for 2 days is equal to 1 plus 2 times of 2, that is 6 units. And now B was replaced by C. Let the 1 day work of C be P units. And A and C finishes the remaining work 10 minus 6 equal to, that is 4 units in 3 days. Hence 4 upon 1 plus P equal to 3, that is 1 upon 3. P equal to 1 upon 3. So the 40% of the work, total work, is equal to 10 into 40 upon 100, that is 4 units. So C alone takes to finish the 40% of the work is equal to 4 upon 1 upon 3, that is 12 days. So the option correct here is option D. Now, question number 19. Raju can finish a piece of work in 20 days. He worked at it for 5 days, and then Jacob alone finished the remaining work in 15 days. In how many days can both finish it together? So the fraction of work done by Raju in 5 days is given to be 5 upon 20, that is 1 upon 4. The remaining fraction of work is given by 1 minus 1 upon 4, that is 3 upon 4. Jacob finishes the remaining 3/4 of the work in 15 days. So this is given in the question. Therefore, the Jacob finishes the whole work. So if Jacob has to do whole work, then he would do in 20 days. 15 into 4 upon 3, that is 20 days. So now Raju takes 20 days, Jacob takes 20, so the LCM is 20. So the 1 day work efficiency of Raju is 1 and Jacob is 1. So combined, they would do 2 units of work in each day. So therefore, time taken by Raju and Jacob to complete whole work is going to be 20 upon 1 plus 1, that is 10 days. So the option correct here is option A. Question number 20. A work twice as fast B, A work twice as fast as B. If both of them can together finish a piece of work in 12 days, then how many days B alone can do it? So the efficiency is also known as 1 day work. Let the efficiency of B is 1, then the efficiency of A is going to be 2. So this piece of information is given here in the question, which says A work twice as fast as B. So if B completes 1 unit of work in a single day, then the efficiency of A is going to be 2. So time taken by A is unknown, time taken by B is unknown, and but the combined work done, time taken is known, that is 12. And efficiency of A is 2, efficiency of B is 1. So the combined efficiency of A and B is 3. So the 1 day work into time will give us total work. For A plus B, efficiency is 3 and time is 12 days. That means total work is 36 units. Therefore, B alone can do it in total work upon efficiency of B, that is 36 upon 1, that is 36 days. So the option correct here is option D. Question number 21. A is 30% more efficient than B. They together can complete a work in 39 days. In how many days A alone can complete the same work? So let the efficiency of B is 100. So it is given that A is 30% more efficient. That means A is faster than B. So if B does 100 units of work in single day, therefore A will do 30% more, that is 30 units more work. So the efficiency of A is 130. But time taken by A is unknown, time taken by B is unknown, but combined they do it in 39 days. So the 1 day work efficiency of A is 130, 1 day work efficiency of B is 100. So combined work efficiency is 230. So now the efficiency of A plus B is 230 and time is 39. Therefore, the total work would be 230 times of 39. Therefore, the time of A is equal to 230 times of 39 upon 130, that is 69 days. Hence, the correct option here is option B. Question number 22. A and B can do a work together in 18 days. A is 3 times as efficient as B. In how many days B alone complete the work? So let us suppose the efficiency of B is 1. Therefore, the efficiency of A is 3. Hence, the efficiency of A plus B is 4. Okay. And the time of A plus B would be 18 days. So this all information we generated or we observed from the question. And now the time taken by A individually and B is unknown. So the LCM is also unknown, total work is also unknown. But we know the 1 day work that is done by A is 3 units, and in a single day we can do 1 unit, and combined they do 4 units. And A and B took 18 days together to complete it. So the hence total work is A 4 times of 18, that is 72. So 72 units is the total amount of work. So the time taken by B will be 72, that is total work, upon the efficiency, that is 1. So 72 days. So if B have to do a work alone, he would take 72 days to complete it. Question number 23. A and B together can complete a piece of work in 15 days. B and C together can do it in 24 days. If A is twice as good as workman as C, then in how many days can B alone complete the work? So A plus B combined do it in 15 days. B and C combined do it in 24 days. So the total work is 120. And 1 day, in a single day, A and B do 8 units of work, and B and C in a single day do 5 units of work. And it is also given that A is equal to 2C. So 2C plus B equal to 15 and B plus C equal to 24. So we have two equations now, and we can solve both of these, and we get the efficiency of B and C. So the efficiency of B is 2 and efficiency of C is 3. So the time taken by B to complete the work is 120 upon 2, that is 60 days. So the option correct here is option B. Question number 24. A can do as much work as B and C together can do. So looks like A is a lot efficient than B and C. And A and B can together do a piece of work in 9 hours 36 minutes, and C can do it in 48 hours. What is the time in hours that B needs to do the work alone? So we have been given that A plus B equal to 48 upon 5 and C is equal to 48. So this information is given. So the LCM is 48. That means the total work is 48. And the work efficiency of A and B together is 5 and C alone is 1. And so the combined work efficiency of A, B and C is going to be 6. So efficiency of A equal to efficiency of B plus C. So this is already given in the question to us. So the efficiency of A plus B plus C is 6. That is already computed by us in the previous slide. So now putting A in the place of B plus C is 2A plus A, that is equal to 6. So 2A equal to 6, that means A equal to 3. So the efficiency of A plus B is 5. Efficiency of A is 3, hence the efficiency of B is 2. So the time taken by B to complete the work will be 48 upon 2, that is 24 hours. So the option correct here is option B. Now, question number 25. A piece of work was finished by A, B and C together. A and B together finished 60% of work and B and C together finished 70% of work. Who among the three is most efficient? So let the total amount of work be 100 unit. So work done by A and B together is 60 unit. Therefore, the unit of work done by C is 40 units and the work done by B and C together is 70 units. Therefore, the unit of work done by B is 70 minus 30, 40, that is 30 units. The unit of work done by A is 60 minus 30, that is 30 units. Hence, work done by B is 30, work done by C is 40, and work done by B is 30. So it is very easy to see that C is most efficient with 40 units of work each day. So the option correct here is option C. So that would be all for this lecture, and I'll see you in the next lecture with more problems on time and work. Thank you very much.